Hello and welcome to the next Nix Hour. As always, we'll look at the Nix Hour repository where you can upvote issues and create issues if you want something to get looked at, or you can also join the Nix Hour meeting every week and ask questions directly, and those will take preference. So today we don't have any question here in the meeting, so we'll look at issues. We have some that have been upvoted, and maybe all of these aren't that big, so maybe we'll take a look at all of these. But let's start with this one. I opened this myself, but it was asked by someone else. It's the oldest issue in here. Yeah. So new issues. I'm not like nobody's familiar with all the new things that are happening all the time, but I do want to mention there is on YouTube, on the NixOS channel, I believe, on the NixOS Foundation channel. Here, there is this small series, the What's New in Nix series. I believe there's a playlist as well. Yeah, Nix announcements. And yeah, these go over some new features of latest Nix versions. There has been a bit of a pause recently, but between 2.8 and 2.12, but they have released a new video recently. And this is done by some people in the community, but also, so here it's Tumberek, Tom from, he's from Flux. Garbus is also from Flux, actually, but I know there's also Daniel from Tweak in here. So it's a bit of a effort by multiple people. And yeah, so there's that, which kind of keeps you a bit up to date with new Nix features. Yeah, Nix packages. So Nix packages, I'm as you might know, I'm the lead of the Nix packages architecture team, so I should know a bit more about Nix packages. There's of course many things happening. Maybe I'll just try to look into a few. So I know one of the recent things that has been happening, very recent things, is the pkg-config. It's a bit big. Well, let me see. I know it's from Ericsson 2314. It's about, yeah, pkg-configModules. And yeah, that's very recent, merged 4 days ago. And this is about exposing the package config libraries a package provides at evaluation time, which then allows some better checks. So there's this new field, meta.pkg-configModules, which shows you it has this file. And a bit of a background, what is pkg-config? Let's look at this PR. So let me go into terminal. Here, check out this one. And so this is the GTK source view package. So let's try this GTK source view. Once we build it, all right, cached. Let's look at the result here. Oh, that's a lot of things. It's going to share. Oh, actually, so in this case, let's do dot and what was it? GTK source view outputs. Yeah, so it has multiple outputs. By default, the first output is the one that gets built if you just do a Nix build. If you want to build another output, you need to be more explicit about this. So we can do GTK source view. I think there's also output name. You can kind of see also the default output like this. But so this uses the output, the default one. And if you want to use a dev, you can access it like this. Just a brief note, there is lib.getDev. Lib.getDev always gets the dev output if it exists. Otherwise, the output And so this is kind of a backwards compatible way to make sure you access the dev output, because, for example, the hello package currently doesn't provide a dev output. So if you do output name, it's out. But in the future, it might have a dev output if it adds a library. And in that case, hello.out, which would have previously been lib or dev, doesn't point to the same thing anymore. And files might have been moved around. So getDev is kind of a better way to make sure this keeps working. But yeah, so GTK source view. And let's build the dev output. .dev. All right. Now dev, the output gets the outputs with at least Nix dash build get put into the result dash and then the output name. So let's do T is alias T. That's an exa alias. X is kind of like ls. But yeah, let's do result dev. And so we can see all the files in here. And this is the relevant bit here, lib.packgConfig GTK source view 3.0. Interesting. And so this is the file name of this matches the meta field now. So eval-a GTK source view .meta.pkg-configModules, and we can see this in here. And I would have to refresh my memory what exactly the benefit of this is. But so just pkg-config, what is that even? If we go into, well, let's do a Nix shell, Nix shell-p, pkg-config isn't available by default. It's, I guess, Nix shell. I don't think it's available by default. No, so let's add it, pkg-config. So pkg-config allows you to discover packages for C library building. You can use --list all to list all of the ones the binary can find. In this case, it doesn't find any. There is a pkg-config. Actually, it doesn't exist by default. Okay. But as soon as you add some package, so let's say we add OpenSSL and then list all, we can see that it can find libraries in the environment. See, oh yeah, now it's set. I see. Oh, is it? It's not the variable I expected. Okay, pkg-config path for target. That's apparently the one. So the shell kind of makes sure that this variable is populated, and this way pkg-config, the binary, can find these files in here. So in this case, we can also do the GTK source view. Let me also make sure I'm not using, so Nix shell by default uses the kind of impure way of referencing Nix packages. If we don't want that, we need to pass -i, Nixpkgs equals. I think dot also works. All right. Well, for pkgConfig, it doesn't matter. This worked before as well. Oh, we can see a lot of things here now. That's, I guess it kind of re-exports all of these dependencies as probably propagated build inputs. Yeah. And so there's both this new pkg-configModules, and I believe there's also a JSON file that kind of mentions defaults. And actually, that might be the kind of reason this is done. Let's go in a convention, add to a few packages, more modules. This one. It might not be, no. pkg-configModules, let me search for that. Oh, default pkg-config. Yeah, actually, that seems relevant. It's default pkg-config packages. Where is it? Default pkg-config packages as this. Top level pkg-config. Oh, here it is. This one I was looking for. So this is a JSON file that maps package config names to attribute paths that provide those packages, as in that's a default, a kind of good default. And so in here, so this kind of allows you to, or allows tooling to discover that, oh, if I need an OpenSSL package, where can I get that? And oh, apparently it's called lib.SSL. So the tooling could look into this and see, oh, lib.SSL, that's provided by OpenSSL. And then by having this in meta.pkg-configModules, we can kind of check that this is actually true, that OpenSSL does actually contain lib.SSL. And so there a new tester has been added, and we see this in the PRs here. So if we go back here, we can see this here. Pass through tests pkg-config testers and test meta pkg-config. So testers, we looked at this in a previous episode as well. That's a set of derivation testers you can use to kind of have very easy ways to test a derivation. They're not super powerful, but useful. Let's briefly look at this in the Nix manual. Testers here, chapter 13. And so we have these, and this is the unstable manual. Let me get the stable manual. Let me go to the unstable one. And yeah, it has pkg-config module. Is that the one? Test. It's okay. That isn't here yet. Maybe it's that new. These do look very similar though. But so yeah, if we go into, let's look at this. I forgot what the package was again. Let's use ffmpeg will be annoying to test. Oh, actually, no, that should work fine. Let's go into ffmpeg and let's go to full one, maybe. Nope. pkg-config module. ffmpeg. No, it's not here yet. Oh, GTK source view was it earlier? I'm a bit slow here, but bear with me. GTK source view, meta pkg-config modules. Okay, that exists. And so there's this tester we can run. So tests.pkg-config. So this was set as a test to make sure this exists. We can build this. Should succeed. Yeah, it succeeded. Otherwise, we wouldn't produce an output. But now let's try to make it fail by doing an override attrs. Let's do this here, and let's set meta.pkg-config modules empty list. Oh, actually, no, empty list, that will still succeed. We need something like foo, something that it doesn't provide. And yeah, we can see package config module foo was not found. So yeah, by adding this test, this gets ensured that it's correct, this meta field. All right, so that's one thing. It is useful for especially tooling that interacts with other package managers. So know that, for example, Cabal to Nix actually started out with an internal such mapping. And I believe this is where the default list even came from. Well, I don't really want to search for it in here. It's probably somewhere in here still. But yeah, it's a common thing to want to be able to like have this mapping.
Would it be feasible to add such test to every derivation that has this meta variable?
I asked myself the same thing. I think that's so adding it to pass through might be a bit weird. So it would be part of make derivation. So if we make derivation, it would be in here. Maybe that's not done yet because it is kind of a very low level and it would influence like actually every derivation as to the evaluation time, but I'm not sure if that's a strong enough reason to not do that. It seems like, especially since it only happens if you add meta.pkgConfigModules. So yeah, I think that should be considered, and that probably was considered by John Erickson, and Robert Hensing is also involved here. Yeah. So let me just think for a second. Other new things I can think of. Oh, we could look at, so just a small gripe with Nix packages. There's so many PRs that you have a hard time knowing what are actually kind of significant updates to Nix packages, because 99% of them are just package updates. So it really, the other updates get kind of lost in the sea. We have a question in chat. Do you know why Nix uses multiple outputs for a single package to provide dev libraries, and what the benefits are versus like in Debian where you have separate -dev packages? So the benefit, the benefit of separate outputs is that when you only need one output, you don't need to fetch the other one. So for example, I know that I think GHC might be a good example. So we have, let's look at it like this. No, let's do this. So GHC, I believe, is quite big. So if you look at the, what? No, it's not that. I just want to like show the closure size. Oh, Nix path info. There, found it. So let's do this. Result, GHC, 2.5 gigabytes. But I believe the docs are built separately. Doc, yes. Let's see about this doc. Oh, the docs are also 700 megabytes. So I guess here it's still significant in any case. But if people don't need the GHC docs, they don't need to fetch them. And that is really the main reason why these separate outputs were done. And why not as a separate entire package? Yuri?
Yeah, I would like to I think the derivation in Nix is comparable to a source package in Debian. So source package in Debian is basically one source that can produce multiple packages. And in Nix, essentially one derivation can produce multiple outputs. And the end result is essentially the same, but in Nix it is called outputs, and in Debian it is called package.
Package.
Yeah, yeah, and so right, you have the compared to building it as a separate package, as a separate derivation, you have the benefit that you only need to build it once, right? And then you have these multiple outputs instead of having to build it twice. Yeah. And all right. So yes, and here maybe we can briefly try in here. So if we want to kind of look at, like, ignore the package updates. I believe there is, so there are labels we can use to filter some things out. So has package update, and maybe you want to only see the package updates, but I see they're not applied to, well, for example, here. They're actually applied fairly sparsely. So that might not work super well, to be honest, but we can click on labels to filter only for those. And then we can put a dash in front of here to make it have everything except those labels. I believe you can also do it in here, probably. Yeah. Alt click to exclude labels, and or also exists. So yeah, but we still have, oh, this is module update. I wanted to do package update. So package update, let's exclude this. And yeah, we'll still have mostly package updates. There's also package new here, I see. There's rebuild counts. We actually can't use this very well. So maybe something else we could do. So these are all open PRs. They aren't merged yet. We could also include this. We could say is merged, I believe, is closed. Closed. I believe there's something else as well. But anyways, we can look at the just commit history as well. And maybe a good, like, I'm a fan of lib. Lib is useful for most people that use Nix. And so how about we just look at here, at the history here, and see if I can spot anything that I know anything about. Oh, and yes, oh, that's weird. My browser just crashed. Can you still hear me?
Yep.
Yes.
All right. So let's get back here. Lib. So yeah, the thing I can briefly mention here is, well, this is, I mean, it's just something I've been working on. And this is why I know about it. So it's lib.path.append. Let's go to the PR, and maybe let's go to this issue here. And so this is a small effort I've been working on to implement some path functions in Nixpkgs to improve handling of paths. And so the first two have been merged here. We have some subpath handling, and we have some path appending. I can just briefly show what these do. So let's go into Nixpkgs. Let's do Nix REPL, make this a bit bigger. And Nix REPL for lib. All right. So we have a path.append. This is a very simple operation. You just take an absolute, a Nix path value, and you append some sub path to it. Oh, my font is really weird after a recent NixOS update, but it's working fine. So you just append a subdirectory to this path. And you can do the same thing using this. You can do this as well. No, actually, like this. This also works, but it's very easy to mess. Oh, actually, this is kind of, oh, no, this is right. But it's kind of easy to mess up something here. So, for example, we have, if you have just foo, this points to /foo, and then we can point to some home directories. Let's point to the lib directory itself. And when you import this, it gets, or when you interpolate this, it gets imported into the store. That's how paths work. But now, what if you prepend or append this to an existing path? you get this kind of thing here. So you have the home directory or the current directory, plus then again, the kind of another directory. And I mean, we can do this as well. And this is just kind of unsafe and unexpected. And so the lib.path.append, that prevents things like this. So when you do that, it's going to say, well, the second argument isn't valid. It's a path type and not a string. And similarly, if you try to append an absolute path like this, it's going to complain about this. You can only append relative paths here. And so in this case, you need this. You can also do multiple directories in here. It's also going to complain about doing things like this. So it's not just a general append operation. It's specifically meant for paths. And that's about it. It kind of just makes path appending safer. Yeah, oh, and also, by the way, this is important. If you try, let's try this. But this gives an unexpected result. So it doesn't actually concatenate with slashes in between. It just kind of does string concatenation. This way you easily end up with kind of wrong results like this, or unexpected results. And so the right way to do it is to add a slash here. But that's easily forgotten, and having that in an operation is kind of nice. And then also other operations are subpaths. So subpaths are kind of like relative paths, but a bit more limited. So we can look at is valid. There's is valid. So just foo, that's subpath. We have foo bar, also subpath. We can prefix stuff. Absolute paths are not subpaths. It's only relative paths. And also, if you have a dot in there, that's also not a subpath, because with dot dots you can kind of escape the current directory or the focus directory, and that isn't really super safe in Nix a lot of times. Then we also have a normalize for this. So we have you can pass foo bar. That's gonna make sure it's prefixed with a dot slash. It's gonna remove trailing slashes. It's gonna also complain about when you have invalid subpaths. Yeah. So this is by itself, it's not super useful, but there are some use cases that require something like this when you want to compare subpaths. I also plan to implement source filtering based on kind of standard naming like this. Well, it's still a bit not super clear how it should work, but that's what I'm going for. And then we also have some other operations that have PRs with them. We have joining of subpaths. We have comparing subpaths, finding out what is the common ancestor of two paths. We have ordering of paths. And from this, the end goal is to implement source combinators. So source combinators is kind of a PR by Robert. It's a bit older already, but it has good ideas. And this is kind of creating a solid foundation for having these source combinators, which will then allow combining sources, especially combining multiple sources together into a single one, which is useful. Yeah. So I don't want to talk too much about that. Let's also go in here. Maybe I can show that I merged this PR last week. This is just a simple replicate function. Allows you to repeat an item multiple times. Very simple. We have that's not related. We have concatLines. That's also new. I merged that. So concatLines allows you to just concat multiple strings together with lines in between, and it inserts an ending new line as well. Sometimes useful. Standardized attribute type set. Oh yeah, we have that. That's doc related. We have some system updates. Oh yeah, there was this discussion. So maintainers newly don't require specifying an email. So the email field was made optional. This was done because some people have used the like a GitHub no reply optional. Some people have used a GitHub no reply email as their email, one like this. And this is of course not the point. If you provide an email, you should be reachable via that email. And so because that wasn't always the case, email was made optional. But instead, it's now required to have at least one of a GitHub email or a matrix ID, so the user is reachable by any means. So that's something new. Let me see if there's anything I can see here. It's just docs. Maybe I could talk about something else I made. This is a bit older though. Let me go here. This function here. Actually, this is kind of hard to see. Let me go to the Nixpkgs manual. I believe it's only in the unstable manual because not all the functions are rendered since all the time. ManyAttrsByPath. So yeah, this function. And so it looks a bit complicated. It is a bit complicated, but so it allows you to kind of deeply override attributes in a very lazy way. So here we have an input we said a.b.c equals something, but then we want to say, oh, let's a.b.c, this attribute path should get increased by 1. And so in here, we can see the result here is indeed, yes, that attribute path was increased by 1. But we can also do other things. We can say, this path should have a D attribute that contains the same value as C. And we can say xy should get a new value that's an xy. And so yeah, this is kind of just a very generic way to deeply update attribute sets. And so you might wonder, what is the difference to recursive update? So this is a fairly commonly used function, and it's a lot simpler to use. So it's just it's kind of like an update operator, but more recursive. And so you can do things like this, which is almost the same. But so there is a slight problem with this, and I have ran into this, which is why I created this function. And that is that if you do recursive updates, lib.recursive update, and let's say we have an error in here. So let's say a equals throw a. Now we want to override that attribute. So let's say a equals null. So we want to remove the error essentially. Then this doesn't work because the recursive update is, due to how it works, it has to be a bit stricter than expected. So because it recurses into all the attributes, it also needs to recurse into this a here and discover that, oh, is a recursive attribute set I should recurse into or not. There might be something here where actually there might be a way to make it a bit better. But so yeah, with the lib.updateManyAttrsByPath, that works because you can say, oh, well, it's a bit annoying to use, but you can say the attribute path is a, and the update is, we ignore the previous value and we set it to null. So we can say a equals throw a, and now we get the overridden thing here. Yeah, if you actually want to use this, I think it sometimes works well to kind of generate this from other code. Well, if you have a use case which requires like overriding a lot of attributes, you can generate this kind of more straightforward without having to type it all out. That was also the use case I had. Do we have a question or I mean, something else you want to ask or something you're curious about in Nix packages? All right, if no one, then I think I don't want to ramble too much about these new things, and it's hard to know when new things have been done on a large scale. Yeah, so maybe let's go back to the repository here. I'm gonna, for now, probably still have this issue open since there's always a chance to look at new features. I think we might look at new features as they come up in future Nix hours. That might work better as a format. We have 20 more minutes. How about looking at this issue as well here? So lifecycle of generic build. So that's lifecycle hooks of generic build, writing some derivations where building is the main concern, configuring patching substitution. Yeah, phases. Yeah. So how that works, let's go for a very simple package.nix. Let's do our generic input.nix packages here. And let's write a package. So std.make derivation, the standard builder, give it a name, test, and let's see what happens. So Nix build package.nix. So yeah, we can see first we have to provide a source. And so we can also see this here, unpacking sources. So there are phases in the builders, and the first phase of those is the unpack. I believe the first one is the unpack phase. We can check the default value for the phases in that is defined in here in setup.shell. This is, by the way, a script that's sourced for every build. Well, if you use make derivation, and it's also in the inputs, I believe. Anyways, let's look at it here. Setup.shell. Let's look at phases, and we can see the default phases defined here. So we have pre-phases. That's also a thing, but the first one that's run by default is the unpack phase, patch phase, configure phase, build phase, check phase, install, and then fix up and some more. And so unpack phase exists by default. All of these exist by default, I believe. We can look at it in here, what it does. And yeah, so we can see all phases have this hook mechanism built into them, by default at least. So they all have a pre-hook, which they run before the phase hook runs, and a post-hook at the end down here. The run hook function, you can also, well, let's look at this later. But so what it does, it looks at source and tries to unpack that. We have checks for source existing, we have structured attrs, it registers the directories that exist before in the current directory, then it unpacks the source, and then it makes sure that new directories have been created in the current directory. It's a bit weird how it works, but that's it's not that terrible. And yeah, so if we want to have that phase work correctly, we need to provide a source. And we can do this, well, source, it's anything that kind of can be turned into a path. So /dot would work. I don't really want to include all the Nix packages, and we should probably do some source filtering here, but let's not do for now. I'm just going to do lib here. And if we do this, it's going to continue. So we can see unpacking source archive. Okay, that works. Then we can see we go to the patch phase. But what we can also do, so we saw that the unpack phase by default looks at source, but we could also override the unpack phase. And so this is not recommended by default, but we can do this, and let's just see that it works. So let's just do echo. This is the unpack phase. Let's build this, and we can also see it continues. It runs our phase, and it doesn't complain about source not existing now. So this way we can kind of override all of these phases, but because there are these standard phases, and people might want to override these. So here, let's actually try this. So someone might say, oh, after the source has been unpacked, I want to do something to the source. So they might do an override address here and do a post unpack. So post unpack, that's the hook that people should be able to hook into. And now here, let's say echo, this is the hook. And let's also exit one just to make sure that it actually runs. But, well, in this case, it continued to the install phase and so on. So the post hook didn't run. And that is because nothing is telling the post unpack to run after the unpack phase. We have to encode this in here. So we have to say run hook post unpack. And once we have this, we get this is the hook message here. And for completeness, we also want the pre-unpack. And so this is kind of how you implement, how you'd have to specify the phase if you actually want to override it completely. But because this is kind of hard or easy it's easy to mess up. So this is not generally recommended. So instead, so in this case, if we don't want to run an unpack phase, for example, like because we might not have source, there is a don't unpack. I think that exists for pretty much all the phases, which we can set to true. And so don't unpack, well, yeah, actually we won't be able to run, to have a post unpack hook then either. But this allows us to kind of ignore the source, and it's just going to jump straight to patching sources, which I guess also doesn't make a lot of sense here. Yeah, we had a question on YouTube just briefly. So yeah, about the you can't reach people on GitHub by ID. And yes, that is true. So it was about the email optional. Yeah, so you can't reach emails, people by name here, just like this, because most people don't have an email. Oh, I probably shouldn't like share the email of a random user. But some people don't have an email. It's not optional in GitHub. And so, yeah, that doesn't work, and that's true. But it's since maintainers do contribute packages and do have to maintain issues and so on, I think it's also fair that they can get pinged publicly in an issue about this. I guess it doesn't work for security critical bugs that might involve them and that should be fixed. That is a small oversight, that's true. But yeah, they can still get pinged in issues, and especially, right, you can create a Nixpkgs issue and ping them in that to kind of contact them. Yeah, jumping back to this, we're switching context here. Yeah, so this works. Okay. But right, we can also just do post unpack here to customize the phase without having to do this overriding and ensuring that the run hook still works. And so in here we can say this is the first unpack or post unpack. And so these hooks, they get concatenated together, or not concatenated, they get all run, which I guess is the same as concatenation. So we should be able to do this twice here. And let's try it. Oh, we don't have a source here still. That's true. So let's change this to pre-unpack. All right. This is the hook. Oh, it gets. I bet it gets run in reverse. Let me remove the exit here. Ooh. Well, I might be wrong then. I thought they would get. Oh, we have to manually do this here. Right. Fair enough. So they don't get concatenated automatically. That's not great. But yeah, so this way you can add to the unpack phase without having to do this overriding thing here, this run hook thing. And actually, yeah, well, to be honest, well, this is kind of the standard, so people are kind of used to doing this. It could still work if you did this, like even without the run hooks, because people could still do something like this: unpack phase equals old.unpack phase. But this is not very conventional, I'd say. Yeah. We have a comment that says it would get concatenated if we were using the module system for packages. Maybe, yeah. That's another discussion, though, entirely. But yeah, so this kind of pattern, this we have unpack phase, we have pre-unpack, we have post-unpack, we have don't unpack. All of these kind of exists for all the phases. And a lot of these phases have a default that does something as well. So we can, so I know what is the default build phase as well. Let's look into this here. So build phase, let's go in here. And yeah, we can see this is make specific. So we have checks for make file. If it doesn't find one, it complains that there isn't one and then skips it. All right. If there is one, it's going to run make with some flags you can set in the environment. Kind of similar, the install phase. This runs, let's see here, make install by default. Yes. Yeah, what is the use case for additional phases? That's, I mean, it's kind of the standard, I'd say, is the use case that you can pretty much take any function, any package in Nixpkgs, and if you need to patch it, you can override the patch phase. So let's kind of push this to the bottom here. So we can pretty much take any package. I mean, let's take hello, just for demonstration purposes. If we want to patch something, we right, if we just had a single phase for everything, and would just say like phases equals old dot phases plus something, this would be problematic because it would run after all the phases have been run already. And so this would be after hello has been built and installed and tested already. But if we want to patch the source, we need to do that before it gets built, but after the source has been unpacked. So by knowing that, oh, we have these standard phases, we can say, oh, post patch, we need to do something to change it a little bit. So then we can go in here and we can do like, let's do an ls, and let's try this. Oh, packages.hello. Oh, yeah, okay, it worked. Let me exit one. And yeah, so we can see here we have the hello source, and we can kind of modify this, and anything that we do here will influence the build. Yeah, that's pretty much the reason. The ones that can, I mean, the ones that can be added to the list of the phases in the between the standard ones. Oh, I know what you mean. Oh, so phases. So I guess you mean these ones are like pre-configure phases, pre-phases, pre-install, pre-build phases. I believe that just came to be from. Actually, I haven't encountered a lot of use cases for these, but I guess we should be able to find some if we grep for these strings. And okay, so I guess pre-build phases, pre-build phase. Yeah, okay, so apparently you can declare additional phases here. That's interesting. In this case, I think it's used when, well, in this case, we have a build system that might want to do some builds on its own before using the standard build. And if it were overriding the standard build or using pre-build, the ordering might get a bit tricky. To be honest, like the phases is entirely kind of an ad hoc system for getting some ordering into package builds. But it's not perfect because, right, in the end, you often end up just concatenating phases together. Like even here, if we want to keep the old post patch, we need to do this. We cannot inspect the old post patch and then insert our code here somewhere in between the actual comments. And so the more granularity you have, the more exact you can be with ordering. But it also gets harder to standardize the names, and people might not know about the names. In Nix packages, the make derivation builder is to find those. So I believe that might have kind of evolved over time, that people were needing some extra phases and some extra ordering standards, and they were introduced into make derivation so that they can be used in the packages. Do all phases run inside the same sandbox? Yes, all phases are run by the same shell as well. So you can also do post patch. We can say foo equals bar. Then in let's see, pre-configure, we can say echo foo. Yeah, so all run in the same sandbox. Oh, yeah, that doesn't exist. Yeah, it's printed here. Are there different limitations to different phases? No, the phases are pretty much freeform. There's nothing that really restricts you in any way what you can do in them. The only thing that kind of influences your decision why you might want to use one phase over the other is the standards. Well, the standards and the defaults. So right there is these default stdm generic, these default actions in here. So install phase and make install. We have also fix up phase. I'm not sure if that's specified in here, but there is, yeah, there's some like substituting and so on going on in here. I believe there's also some binary fixing up in here. So you don't want to override these. You might want to have actions before or after these default actions, and you don't want to like explicitly specify them all the time. Yeah.
But specifically, this means that when you're not allowed to fetch from the internet inside a face, for example, all that has to be done beforehand and using Nix's other mechanisms for fetching stuff.
Yes, yes. Except when you have a fixed up derivation. Then you could use fetch from the internet. But yeah, if you need something from the internet interface, well, we are out of time, just 1 minute. So you can provide source, this is kind of default, but oftentimes you don't want to change the source just to get some extra input from the internet. So you can also just do this, like interpolation in here, packages.fetch URL, something in here. This returns the path to the fetched URL, and that, yeah, this way you can just use something right in line here. Or, I mean, some fetched thing equals fetch URL.
Okay.
Yeah. So yeah, I hope that helped a bit. But yeah, thanks for listening, and see you next week.